So your first problem is find kth largest or kth smallest element in array. Okay, so let's say we have an array like 1, 5, 2, 3, 4. Okay, and we want to find second largest, k equals to 2. That means second largest. So the very first approach comes to your mind. The very first approach comes in your mind is we can do sorting. Correct? If you do sorting, what will happen? Your array will be like 1, 2, 3, 4, 5, right? And you want to find the second largest. If we have distinct elements and you want to find second largest, what you can do? You can just go through this index. Correct? You want to find second largest, you can go through this index. So this will be very basic task, right? You can do it. You can perform sorting. Okay, but how much time it will take? It will take n log n time. That we know, right? That we know. But if we want to further optimize it, we can think of what? K is there. We can think of priority queue. Okay, so don't confuse between priority queue. Whenever I will say priority queue, that means that will be min heap or max heap. Okay, mostly in case of priority queue, by default in C++ we have max heap. Okay, and we can convert this in min heap also. So priority queue by default have max heap that I have discussed in STL lecture, right? So if you have watched all the lectures, you know what is priority queue, you know what is max heap. Okay, so we can think of priority queue, right? That means we can think of max heap. So how we can think of this? So if we want to find kth largest using our heap, so we can do using max heap as well and min heap as well. Okay, in min heap as well. So we can do both ways. Now, how we can do using max heap? Okay, how we can do using max heap? So in max heap, I want to find kth largest. What I can do? I can simply put all the elements here. Okay, so I can simply put all the elements. So we have 1, 2, 3, 4, 5. Like, so we will push 1, 2, 3, 4, 5, something like this. Okay, the thing is the top element will be always maximum. Okay, and there is no relation in left and right child. These are left and right child of this one. Okay, so there will be no relation in left and right child. So these are left and right child of 1 and these are left and right child of 2. Okay, this will be something like 5. Okay, 4, 3, 2, 1, like this. Okay, so there is no relation between the childs. Okay, the only relation is between parent and child. Okay, so in heap the childs can be in any order. Okay, please remember the childs can be in any order, so don't get confused. There is only relation between parent and child. Okay, so parent will be always greater than child in max heap. Now let's assume that this is our heap. Okay, this is our max heap. So how you can find the kth largest? What you can do? I want to find second largest. Okay, so just pop from heap k minus 1 times. Pop from heap k minus 1 time. Okay, that means pop one time. So if you pop one time, now fourth is the maximum. Okay, so this will be our second largest. This will be our second largest, or we can say kth largest. If you want to find fifth largest, so what you can do? Pop 4 times. Okay, one time we have already popped. Pop 3 times also. Okay, so if you pop 3 times, what will happen? We're left with one only. Okay, this will be at top. So our fifth largest will be nothing but 1. Okay, but we know that insertion in heap takes log n time. Each insertion in heap takes log operation. Okay, and deletion time. Each deletion operation takes log n time. Okay, so we are inserting n elements in max heap. Okay, it will take n log n time. Correct? Then we are popping the elements. Popping the elements how many times? We are popping k minus 1 elements. Correct? So deletion time will be k minus 1 out of n elements. So the actual time complexity will be n log n plus k minus 1 log n. Okay, that will be nearly about n log n. Correct? That will be nearly about n log n. Okay, because it will be, if you summarize, it will be n only at max. So this will be, you can say 2n log n, and this will be nothing but n log n only. But if you want to perform it in n log n operation, then you could use sorting only, right? You could use sorting only if you want to perform it in n log n. In fact, you are using 2 times n log n. So this is taking more time than your usual sorting algorithms. Okay, so if you want to perform, if you want to find kth largest using max heap, you can do like this. Now, if you want to use min heap, if you want to use min heap to find kth largest, okay, what you can do, please take care of this, okay, because this is the optimal one. So if you want to find kth largest using min heap, what you can do, let's take the same example, 1 3 2 4 5, like this. Okay, if you draw the min heap, it will be like 1 will be here, then 3, then 2, okay, then 4, and then 5. Okay, no rebalancing is there, right? Because all are in same way. Correct. As I told you, there is no relation between childs. Okay, so they can be in any order. Okay, 3 is more than 2. Okay, so it can be 2 3 also. But the thing is, the relation between parent and child should be in same manner as heap. Okay, so if it is min heap, it should be less than this one. Now this is our min heap. Okay, so how to use min heap, how to use min heap? Okay, what you can do, so what you can do, you want to find kth largest. Okay, so just take a min heap of size k. Okay, take a min heap of size k. So let's say you want to find third largest, you want to find third largest. Okay, let's take in a form of tree only. Correct? So initially it is empty. Now go through this array. Okay, 1, put 1 here. Okay, go through this 3, put 3 here. Go through this 2, put 2 here. Okay, there might be the rebalancing required. Okay, so let's say if it is something like 3 1 2, okay, then 3 1, so it will be 1 here, it will be 3 here. Okay, so the rebalancing will be there. Okay, now I have inserted k elements, I have inserted k elements in heap. Now move forward. Okay, so if you come here, it is 4. So if it is greater, if it is greater than our root element, what I will do, I will just pop this out. Okay, pop out and push this in. Okay, so what will happen, just do this, just do this one. Okay, okay, just pop this out. First pop this out. So if you pop this out, what will happen, I will swap this, right? You know how to perform deletion, right? We will just push the last element to the root. Okay, so put this, so 2 will be here, right? And there will be no child. Now push 4, so push 4. Okay, and as this is following the property of min heap, no rebalancing is required. Okay, now come here, 5, to check our current element is greater than your priority queue top. Okay, priority queue top. Then what you will do, if that is the case, just pop out the element from priority queue. Okay, and push current element in priority queue. So push 5 here. Okay, so first pop this out, pop 2. Okay, and 4 will come here, 4 will come here. Okay, remove this. Now rebalancing is required, so rebalancing is required. So 3 will be here, I will swap this, 3 will be here and 4 will be here. Okay, I am doing nothing, just rebalancing the tree. Okay, to form the min heap property. Now I will insert 5. Okay, I will insert 5. Okay, now move forward. So there is no element left, there is no element left. Okay, so the top the top element will be nothing but our kth largest element. Okay, the top element will be our kth largest element. Now why this is working, let me tell you why. Okay, so if we have some array, okay, 1 2 3 4 5, and we have a heap of size k, we have a limited size heap. So every time greater element is coming, we are removing the minimum element. Okay, so at the end it will contain only k elements. Okay, k largest elements, it will contain only k largest elements, k largest elements. Okay, so if we have, let's say, array like 10 20 30 40 50, okay, in any order, so at the end what will happen, it will store only like 30 40 50 in min heap property. Okay, and out of these k, out of these k elements, okay, out of these k elements, whichever minimum will be our kth largest. Okay, so 30 will be our minimum, 30 will be our minimum out of these three. Okay, so if you want to take fourth largest, if you want to take fourth largest, just take a heap size of 4. Okay, so at the end it will contain four largest elements. Okay, out of whole array, four largest elements in the form of min heap. Okay, so out of these four largest, whichever minimum will be our kth largest element. Okay, because we have four bigger elements, 30 40 50 60. Okay, these are four bigger elements remain out of my array. So whichever minimum out of these, whichever minimum, this is our minimum. Okay, so this will be our answer. So how much time it will take? It will take how much time? We are taking a k size min heap, k size min heap. Okay, and what we are doing, we are pushing and popping. Okay, pushing and popping. So how many elements we can push and pop at max? So let's say this is the size of n size array, n size array. Okay, so every time if we are pushing, so it will take n times we are doing pushing, and every time it will take how much time? It will take log of my heap size. Okay, because it is a let's say k size heap, k size heap. So every time rebalancing will be done in this k elements. So the time complexity will be n into log k in our case. Okay, because this log operation will be done in the number of elements inserted in our heap. Okay, so the time complexity will be n log k. And what will be the space complexity? The space complexity will be nothing but the heap space. Okay, we are taking k size heap, so this will be order of k only. Okay, and in case of max heap, okay, in case of max heap, we will use order of n size heap, extra space. Okay, this will be space complexity. Time complexity will be same as n log n. Why? Because we have n elements in our heap. Okay, so please take care of this. So order of n log k is better than order of n log n. Okay, k is better than n log n. Okay, because we know we are inserting only k elements, and space complexity also we have only log k. Okay, so this is the very first problem of heap. Very standard problem this is. So if you understand this, you can use it in various topics. You can use it in binary search. Okay, so we have done this in matrix problem as well, right? I have given you the intuition in the previous problem in of binary search, how we can use priority queue. Okay, so whenever there will be something like k largest, k smallest, so you can think of heap.